Welcome everyone to section 9.1 in geometry. We're talking about translations. And no, we're not talking about language translations. We're talking about geometric translations. Let's go ahead and start this off. Well, translations is a type of transformation. And this is when you change a shape in geometry. Okay, usually it's on the geometric plane, but it's a change in a shape. From one shape to another. Okay, so if we're thinking about a shape, the pre-image is the starting shape. This is before the change. Okay, so the pre-image is before the change. And usually it's represented with like a dotted line. That means it was there and now it's someplace else. Think of it as like the ghost, okay? So the image is the shape after the change. Okay. So usually we have the pre-image, and it's labeled something like, let's choose purple. We'll call it A, B, C, D. That's the pre-image. And then the post-image will usually be labeled A prime, B prime, C prime, and D prime. That's what the apostrophe is called. This is called A prime. And this just means it has undergone a change, and it's the same shape, okay, but it's just been moved. It has been changed. It has been transformed in some capacity, so it's a little bit different. It's changed in some way. So now we call that A prime, B prime, C prime, and D prime. Okay, so pre-image before the change, image is after the change. Let's move on to rigid motion. So rigid motion is when a shape maintains, I should change this to green, maintains its form but moves in some way. Okay, so it maintains its form. Let me change this to green. Okay, so what's an example? Well, an example would be, let's make a right triangle, or try to. And that was not a good one. Let me try this again. Let's say we have a right triangle. And let's say this has sides of, we'll make this 12, and this 5, and then 13. Okay, 5, 12, 13 triangle. And we could call it ABC, just to be super creative. Okay, now, we could have this undergo a change, okay? And then if it was, let me copy this, and now this is the new shape, okay? So if this is the new shape, and this is the change it has made, and what I mean by the change is it simply has gone, all these points have kind of made a slide here. If this is the only thing that has changed, then that would be a rigid motion. Notice how all these sides are the same length still. Okay, nothing has changed about that shape. That would be rigid motion because it has maintained the same shape. Everything's still the same. It just has moved from one to the other. You're probably thinking, okay, what the heck then is a non-rigid motion? Okay, well, non-rigid motion would look like this. Non-rigid motion, let's say this slides, and then also, let me paste again. Also, it shrinks. So now we have different dimensions, and we'll call it, I'll just call it 0.5, 1.2, and then 1.3. Let's say it goes into those dimensions. Well, this clearly has changed. Those sides are no longer the same length, so it has undergone a non-rigid motion. It hasn't maintained its form. Okay, it got stretched out. Okay, now let's talk about notation. How do we recognize notation when we label these things? Well, if we're going through a transformation, this is the pre-image. Oops, wrong thing. This is the pre-image. Okay, on the right image. I had to think about how to spell it. Okay, then this would be the image over here on the other side of the arrow. So there's our pre-image, there's our image. So in this case, This J becomes J prime, as we talked about. This K becomes K prime, and this Q becomes Q prime. So our new shape would be triangle, J prime, Q prime, K prime, sorry, Q prime. That would be our new shape. And this looks like an example of rigid motion. Notice how all the dimensions look the same. It just has moved from one place to another. Speaking of that, that's exactly what translation is. Translation is a movement, let's say a rigid motion movement. A rigid motion movement of a shape. I like to think of it as a slide. It slides on the coordinate plane. A slide on the coordinate plane. Okay, so here we have A, B, C, D. Notice here we have these arrows drawn, okay? And they're not perfect arrows, but they give us an indication of what's going on here. Now, one thing that's interesting is these arrows have to be exactly the same length. So these distances are the same. Same distance. All four of these distances are the same. So the distance from each vertex has to maintain for each one of those. So that distance from A to A prime is the same as B to B prime, is the same as D to D prime, and the same as C to C prime, okay? Those are all the same distance. I'm gonna draw two more arrows actually. So we have all the same distance right here, okay? That is basically the bottom line of translation. Each vertex moves the same distance. I'll write that here, each vertex moves same distance. Okay, how do we apply it? Well, notation for translation. Oh, we haven't talked about notation for a translation. Well, we'll talk about that in an example, okay? So notation on a coordinate plane. So ABC translated 6 units down and 3 units left, okay? So it's a rigid motion because it says it's translated. That means a slide. And it's going 6 units down and 3 units left. Well, 6 units down, we know that is the y-axis, is up and down. So we're going to go down 6 units. So I like to just start at one of the vertices. We say it's going to apply the same to each one of these. 4, 5, 6 units down. And then we also need to do 3 units to the left. And I know that's my x-axis is left and right. So I'm going to go 3 units to the left. 1, 2, 3. Now, the thing is, I need to do this to each one of the points. I need to do this to A. I need to do it to B. And I need to do it to C. All 3 of these need to go down 6 units and to the left 3 units. Okay, so I'm going to make my new points here, if you can see. Okay, and then now if I connect the dots, and that was a bad attempt. Let me try this again. Okay, there we go. Notice how my shape looks the same. Now, I didn't draw it perfectly, like this line looks a little slanted, okay? But this shape needs to maintain its angles and all its dimensions. It needs to be the same. It needs to be mirror. Yes, I changed color, but it needs to be not a mirror, but a spitting image of its original. Again, this is the image, and this would be the pre-image. Now, how do I notate this? Well, notice how I talked about my y in blue. I went down 6 units. That means I went in the negative direction 6 units. And what did I do with the horizontal axis? Well, I went to the left 3 units. I went 1, 2, 3. So I went left 3 units. So there's negative 3 right there. How do I translate this, or how do I put it into notation? Well, here's a T. The T stands for translation. This is how we write it. This is like the formula for translation. This is our translation equation. Okay? In this first spot, we put our change in x. So in this case, we put negative 3 because we went 3 to the left. Okay, so that is 3 left. Here we put -6 because this is our change in y. For each point, okay, for each vertex, remember, each one's going to be the same. Change in y. Okay, so this is 6 down, as we've talked about. We already said this is going to be our pre-image. Okay, so then we have our image here on the right. So we have A prime, B prime, C prime. Now, you're probably thinking, okay, earlier you said A prime, B prime, C prime. That was the pre-image, or that was the image. Well, you can go either way. It depends on where you start or go to. But generally, you should think of the pre-image as the prime one. So if you want to go back and change that, and then we call this. Let me just shift this over. A prime over here. It's that is an important piece. I kind of got that backwards. So sorry about that. Correction. I would rather call out my own mistakes than have you make your own. Okay, so that's the pre-image, and then we have the image right here. Remember, the image is after the transformation. Okay, so that's basically your bottom line of how to write it out with translation. It looks like a lot, but really it tells you everything that you need to know. Okay, so there is your translation system. Okay, describe the translation here in words, for example, 1. Okay, so in words, we just need to count how far down it goes from one vertex to the other. So let's pick Z here. We see 1, 2, 3, 4, 5, 6, 7, 8 down. So we go 8 units down. Okay, how many do we go to the left? We go 1, 2, 3. 3 units left. Okay, now how do we do it with a proper notation? Well, the T stands for translation, and now we need our little brackets. We're going to put our X, the change in X, on the left. Well, that is -3, 3 units to the left. On the right part of it, we're going to put the change in the Y, -8. It went 8 units down. Okay, and then we're going to talk about sorry, let me just double check here. We're going to talk about the pre-image. So our pre-image is the shape XYZ. And you can actually put triangle XYZ. And then we set it equal to our post-image. In this case, it's going to be triangle A prime, not A prime, X prime, Y prime, Z prime. And that's all there is to it. That's proper notation. It's that simple. You only need to worry about one vertex. Hope you guys enjoyed this video. Sorry for the mix-up at the beginning. Make sure to check out some of my other videos, especially 9.2 coming right up after this. Thanks for watching.